Hello everyone, myself Chandrasekhar once again welcoming you all to this beautiful Sunday Ka Funda series. As you all know, in this series we discuss an important concept through practical demonstration और through the real life usage. इसी सिलसिले में आज मैं फ्लूइड मैकेनिक्स के बहुत ही बेहतरीन कॉन्सेप्ट का डिस्कशन करना चाहूंगा थ्रू ए प्रैक्टिकल डेमोन्स्ट्रेशन. उस कॉन्सेप्ट का डिस्क्लोज मैं नहीं करूंगा. लेट अस ट्राई टू ऑब्जर्व द एक्सपेरिमेंट एंड ट्राई टू फाइंड आउट व्हाट दैट कॉन्सेप्ट बिलोंग्स टू. तो मेरे पास एक ट्यूब है, ए होलो ट्यूब विच इज ओपन एट बोथ द एंड्स, कंप्लीटली होलो. इस ट्यूब में अगर मैं कोई लिक्विड भरता हूं, लेट मी ट्राई टू पोर इन सम लिक्विड. It is the colored water. Let us see. Yes. Can you see? So there is a colored water I have poured into the tube. तो यहां पे अगर आप ऑब्जर्व करेंगे, द लेवल ऑफ लिक्विड इन बोथ द लिम्स इज सेम. अगर मैं किसी भी लिम को ऊपर करता हूं, इफ आई इंक्रीज द हाइट ऑफ वन ऑफ द लिम, देन ऑल्सो देर इज नो चेंज इन द लेवल ऑफ लिक्विड. इवन आई डिक्रीज द हाइट ऑफ वन ऑफ द लिम. कैन यू सी इट? इवन इफ आई चेंज द हाइट ऑफ द लिम्स, देर इज नो चेंज इन द लेवल ऑफ द लिक्विड इन बोथ द लिम्स. अगर मैं, क्यों ऐसा है? क्योंकि दोनों लिम्स ओपन टू एटमॉस्फेयर है. अगर मैं किसी एक लिम में प्रेशर इंक्रीज कर दूं बाय ब्लोइंग सम एयर, लेट अस ट्राई टू ऑब्जर्व. कैन यू सी? सो आई हैव होल्ड द लेफ्ट लिम. आफ्टर ब्लोइंग द एयर आई हैव होल्ड इट यूजिंग द थंब. तो यहां पे लेफ्ट लिम में प्रेशर ज्यादा है, तो प्रेशर अगर ज्यादा है तो लेफ्ट लिम में लेवल ऑफ लिक्विड इज डाउनवर्ड एंड द राइट लिम में लेवल ऑफ लिक्विड इज अपवर्ड. देयर इज अ डिफरेंस इन द लेवल. अगर मैं इसको थंब को छोड़ देता हूं, देन द लेवल ऑफ द लिक्विड विल अगेन बिकम सेम. अगर मैं इस लिम में प्रेशर को कम कर दूं बाई सकिंग इन सम एयर, लेट अस ट्राई टू सी. एंड होल्ड इट थ्रू द थंब. अब देख सकते हैं थंब जैसे छूटा वैसे ही लेवल. Hello everyone. So guys, welcome back. So now let us try to understand the most important and the beautiful Pascal's law. The Pascal law is actually applied to the static fluid to relate the static pressure of the fluid. So let us try to understand the Pascal law in three important statements. The first statement of the Pascal law says that pressure at any point in a static fluid is same in all the direction, because pressure is a scalar quantity. So the pressure, static pressure, will be equal in all the direction. So you can understand this statement through the animation which is there on the screen. So if you push the plunger, if you apply a force on the plunger, normal force, then that will develop the pressure in the fluid which is kept in the container. And the container is having minute holes all around. So whenever you push the plunger, when you develop the pressure in the fluid, the pressure developed, the static pressure developed will be same in all the direction, and you can observe that there will be uniform flow from all the direction. The flow will be same from each and every hole, and the flow is because of the pressure, high pressure, which is developed due to the motion of the plunger, right? Even in the flowing fluid, even in the moving fluid, the static pressure will be same in all the direction. Whether the fluid is flowing or stationary, it is always the static pressure at any particular point which will be equal in all the directions. So the Pascal law is applied to the static pressure only. So another statement will give a better clarity to the Pascal law. Let us understand the second statement. External static pressure which is exerted on a fluid or which is developed on a fluid. How the static pressure is developed? By applying a normal force per unit area. So the pressure, static pressure which is developed on a fluid is transmitted equally, is transmitted uniformly throughout the fluid in a horizontal plane. So the transmission of static pressure will be uniform throughout a horizontal plane. That is what is called as Pascal's law. And based on the Pascal law, there are so many equipments which are working, like hydraulic press, hydraulic ram, hydraulic jack, etc. So in an arrangement, there is a static fluid kept, because the Pascal law is applied to the static fluid only, or static pressure. It is always about the static pressure. If we apply a force F1 on the plunger, which is having an area A1. So by applying a normal force F1 on the piston or the plunger of area A1, there is a pressure P1 developed here. And at the same, and on the other side of this arrangement, the pressure is developed P2 at point 2. This developed pressure will be exerting a force which is normal and compressive on the ram. So the force developed F2 will be equal to, what is the value of F2? Can we say F2 will be equal to P2 into A2? And what is P1? P1 is equal to F1 by A1. And because the fluid is static and it is a single static fluid, so in case of single static fluid in a horizontal plane, pressure will be same. That is the Pascal law. In a horizontal plane, the pressure distribution is uniform. If we apply an external force F1, it will develop F2 force. So F1 will not be equal to F2, but yes, the ratio of F1 by A1 is equal to F2 by A2. So if we apply 1 Newton of force on the piston having an area of 1 meter square, the pressure developed will be 1 Pascal. If the area of the ram is 100 times of area of the piston, then we will obtain 100 times of force by just applying 1 Newton of force. So heavy objects can be easily lifted using the concept of the Pascal's law. And the third statement will give you more clarity about this Pascal's law. According to the third statement, it says any 2 or more points at the same elevation, at the same height, in continuous mass of same static fluid will be at the same pressure, will always have the same pressure. So there are 4 conditions. There are 4 conditions which are there in the statement number 3. One is the same elevation, means a horizontal plane we are talking about, or same height. Elevation means same horizontal plane. Continuous mass means it must be a single fluid. The points which we are talking about should be joined by a single fluid only. There should not be multiple fluids to join the points. The third condition is the fluid must be static. It must be having no shear stress to be developed. And the fourth condition says the pressure will be constant. So as a corollary of Pascal law, we can say out of these 4 conditions, if any 3 conditions get satisfied, then the 4th condition will also be true. Any 3 are getting satisfied for the points, then the 4th one will also be correct. That can be called as corollary of Pascal's law. Otherwise, the Pascal law says the points must be lying in the same elevation. They must be part of the continuous mass of same static fluid. Then they will have same pressure. But as a corollary, we can say any 3 conditions are getting satisfied, then the 4th one will also be correct. That can be understood in a better way from this diagram. If there is a container having multiple tubes of different sizes, different shapes, if we start pouring a liquid in one of the tube, then what will happen? The liquid will settle at the bottom first. The liquid will fill the bottom of the tank, and then the liquid, we continue pouring the liquid, then the liquid will start rising in the tubes. Then at any instant, if we see the free surface in the tank, in the tube 1, free surface in the tube 2, free surface in the tube 3, free surface in the tube 4, free surface in the tube 5. So as P1, P2, P3, P4, P5 are equal, isn't it? P1 is equal to P2 is equal to P3 is equal to P4 is equal to P5, that is equal to P18 because all the tubes are open to atmosphere. So this condition getting satisfied, same pressure. And point 1 and 2, if we join point 1 and 2 through the fluid, we are traveling in a single fluid, either from the bottom or from the top. We are traveling in a liquid only, same liquid only. 2 and 3 are joined in the single fluid, so that can be treated as continuous mass. And the fluid is static because it is not flowing, so it is a static fluid. So this condition is also getting satisfied. So according to corollary of Pascal law, point 1, 2, 3, 4, 5 must lie in the same horizontal plane. So Pascal law is not about the geometry or area of the tubes. Whether the geometries are same or different, it does not matter, but the point 1, 2, 3, 4 and 5 will be in same horizontal plane, will lie in the same horizontal plane. Similarly, if we take the points at the bottom of the tanks, point A, point B is the bottom of the tube B2, point C is the bottom of the tube 3, point D is at the bottom of the tube 4, and point E at the bottom of the tube 5. Now all the points A, B, C, D, E are lying in the same horizontal plane, same elevation condition. If you join A and B, we are traveling in the single liquid, same liquid, so it will be the continuous mass as well. And the fluid, the points are part of the static fluid. So these three conditions are getting satisfied. So according to Pascal laws, the points will have the same pressure. The pressure at the bottom of each and every tube, irrespective of their geometry, irrespective of their size, irrespective of their shape, the pressure at A will be same as pressure at B, will be same as pressure at C, will be equal to pressure at D, and will be equal to pressure at E. So these are the conditions. If you are comfortable or if you understand these conditions, then you will not find any difficulty in understanding the Pascal law. We can apply the Pascal law for a U tube, U-shaped tube. There are multiple fluids, rho 1 and rho 2. Rho 2 is having lesser density than rho 1. The density of rho 2 is less. That is why it is lying above rho 1. Both the tubes are open to atmosphere. Both the tubes are open to the atmosphere. So if we draw a horizontal line like this, so if I ask you point 1 and 2, will they have same pressure? Point 1 and 2 are lying in the same horizontal plane. That condition is fulfilled. Point 1 and 2 are part of static fluid. That condition is also fulfilled. And point 1 and 2, if we join point 1 and 2, either from the top or from the bottom, if we are finding a single fluid, then it will be called as continuous mass. If we join 1 and 2 from the bottom, we are only traveling in rho 1 fluid. So that is why the continuous mass condition is also getting satisfied. So according to Pascal law, P1 and P2 will be equal, right? Similarly, if we draw a horizontal line here, if we take point 3 and point 4, if we talk about point 3 and point 4, point 3 and point 4 are lying in the same horizontal plane. Point 3 and 4 satisfying the condition of static fluid. But if we join 3 and 4, from the top we are traveling in air and then rho 2 fluid. There are multiple fluids, air and rho 2. If we join 3 and 4 from the bottom, again there are multiple fluids, rho 1 and rho 2. So the continuous mass condition is not getting satisfied for point 3 and 4. So P3 and P4 will not be equal, irrespective of the shape, size of the tubes. If A1 is equal to A2 or A1 is not equal to A2. It has nothing to do with the area, shape, size of the tubes. Alright, so my question to all of you is, please do let me know if we take another 0.5 here, so if I ask you the relation between 3 and 5, if I ask you about 3 and 5, will P3 be equal to P5 or P3 will not be equal to P5? Please write your answer in the comment section. And I hope you have enjoyed the session. You have understood the basics of Pascal law. That is all from my side for this session. See you in the next such video. Till then, enjoy, take care, have a good day and a great future ahead.